Okay, this is the MECH1395 hydraulic lab activity number 3. This is fairly basic, just simple reciprocation of a single-ended double-acting cylinder, C1. Up here, we're controlling it with this 3-position, 4-way, open center, lever-operated, spring-centered directional control valve. This black dashed line is the steel manifold block that this valve is mounted on. I've got this valve over here grayed out because it's not used in this activity. You can see its A and B ports don't go anywhere. It's included because these two valves, the lever operated one and the solenoid operated one, they share a P and T port in the block. There's only one and both valves share it. And the way the flow path works is it comes in through this valve and then goes over to this valve and back again. So it's included for completeness, but you could just ignore it and kind of just assume that this flow path is straight through here. As long as we're not touching this valve, it doesn't do anything. We have a flow meter F1 measuring the flow that goes to the directional valve and then potentially to the cylinder, and also flow meter F2 is measuring the flow coming out of our system relief valve, which we have set here. I'm going to set it to 600 psi. And right now the pump is on. We can see it turning. We can see the non-adjustable pressure relief valve built onto the pump that opens at 1000 psi. There's no flow going through it. And we can follow the flow path through here. No flow is going through the relief valve, and hence F2 is 0 GPM. F1 is 1 GPM because all the pump flow is going through here, through this neutral position, through here, and then just freely back to tank. So the system pressure is very low. Now this simulation doesn't fully simulate all of the line losses perfectly, so these pressures won't be exactly what we'll see on the actual test benches. And the idea is you can operate this lever and drive the valve back and forth. This position puts P to A and B goes back to tank, so the pump flow goes through this valve into the retract port and the cylinder retracts, and flow comes out of the extend port and goes into B and back to tank as well. Right now the cylinder is fully retracted. If I click the other valve position, it extends, and you can see the pump flow going into the extend port, coming back out of the retract port and back to tank. Notice while the cylinder is in motion, this 1 GPM on F1 doesn't change. It's always 1 GPM. Similarly, F2 is always 0 GPM while the cylinder is in motion. But once the cylinder gets all the way to one end, it's going to be fully extended in a moment. Now we call it deadheaded. Pump flow is directed to port B of the directional valve and the extend port of the cylinder. So the cylinder fully extends and then it stops, and there's no flow path here anymore. You can see there's now 0 flow through F1, and all the flow is going through the relief valve. You can see this arrow has been pushed into the center, meaning this valve is open now, whereas this relief valve is still closed. It takes 600 psi to open this valve, so you can see the system pressure is 600 psi because this is all connected together. Also, the pressure in the extend chamber, P2, also 600 psi, but P3 is 0 because it's connected back to tank. This is one of the skills in this activity. In order to set this relief valve properly, the way that you do it is deadhead the cylinder, drive it all the way back until the flow is forced through the relief valve, and now adjusting the relief valve, you can see as I adjust the relief valve, watch what happens to P1. You can see it changing, right? It changes to be whatever the cracking or the full flow pressure actually is. Put it back to 600. Right now the cylinder is retracted and deadheaded, but if I were to let go of the lever, the valve gets popped back to its middle position by its springs. And now look, F1 is 1 GPM again, and all the flow is going through the valve neutral back to tank with no resistance. So low pressure here, full flow to the valve, no flow through the relief valve. You can't adjust the relief valve properly in this position. If I were to go and change this pressure now, you see it has no effect. The valve still stays closed, and as I adjust this relief valve, I'm not seeing any change on P1. In order to set the relief valve properly, deadhead the cylinder. Now, when you adjust it, you see that pressure show up on P1, and in fact P3 in this case, because I'm retracted and deadheaded. I hope this helps.